Hi, biochemistry students. Hey, it's time for mass problem solving. So here we go. Let's take a look at the slideshow here. Now, what you want to think here is in a mass problem is like in these types of problems, you're going to see a mass given for a part of the balanced equation. So what this slide here doesn't show you is a balanced equation, but one of the most important parts of all of this is to have a balanced equation. So that's where you start. But once you know what the balanced equation is, then in the problems, it's going to give you a mass value of either a product or reactant. Okay. And then you have to move from that all the way through a dimensional analysis sequence to solving for the amount of mass of what's being asked. So in this case, it's just sort of showing you the process here in this slide. Now let's advance forward here. And let's say we take something like how water is formed. So we have hydrogen gas and oxygen gas forming water. This is a synthesis reaction. Okay, now here's the balanced equation. Now, let's take it a next step further. Now, notice that the problem, it says something about the mass up here. So it has in the reaction between H2 and O2 produces 13.1 grams of water. How many grams of oxygen reacted? So in this case, it's telling you the amount of water produced in this balanced equation here, but it wants you to figure out how many grams of oxygen would it take to do that. It's a great tool that chemists use mass problem solving. So one thing I love about these and this part of chemistry is it's going to pull on every skill you've learned so far. The skill of doing compounds correctly, forming compounds, figuring out equations, balancing those equations, and then mole ratios. It pulls it all together. And so it is going to be fun. So what we're doing then here is we need to figure out what's the molar mass of water and then what is the molar mass of oxygen. So that's the first thing you have to do. Now let's see if it tells us here. So turns out the molar mass of water is 18.02 grams. And so when you set your problem up here, it's really a dimensional analysis problem. So you start with the amount of grams that's given in the problem, which was 13.1 grams of water. And now the next step is you're just going to set up a mole uh, dimension here in which you have 1 mole of water is it's a molar mass value of 18.02 grams. Now, you would have had to have gone to the periodic table to figure that out. Oxygen is like 16 or 15.99, and hydrogen is approximately 1. So that's where they come up with 18. Now, I'm going to be showing you guys some examples. So look for my videos of where I work some of these out on the board. Now, the next step here is to literally set up a mole ratio between the oxygen and the water. So what we're after and what we want to end up with is grams of oxygen. And so we set it up this way. So we have moles of water here. So we set up our mole ratio based on our balanced equation where we have 2 moles of water for every 1 mole of oxygen. So that's why you set it up that way. Now, this is the molar mass of oxygen gas, and that's why it's set up this way. So that when you notice when the units are canceled, grams of water cancels with grams of water. This is a numerator, this is a denominator. That's why they cancel. Moles of water, numerator, moles of water, denominator, cancels out. Moles of oxygen, numerator, moles of oxygen, denominator. That's why you're going to end up with grams of oxygen here based on its molar mass of O2. And so really in a nutshell, that's kind of how these are done. There's some problems here that I will be kind of guiding you along as we go. Okay, I hope that helps. And remember that just keep working hard, okay, and do a lot of practice. And I think you'll end up getting this. All right, thank you for watching.